Okay, so in this video, I am going to show you how to use Gephi to analyze a real-world network. So I've installed Gephi 0.8.2, that's the beta version. So the real-world network is available as a .csv file. So I'm going to open a real-world network, which is I'm going to show you the Karate network. So this is a CSV file given to you. Open it up and make it, it's an undirected graph, so you can choose correspondingly which graph is given to you. For this project, our assignment 2, everybody is given an undirected graph, so make sure to select undirected, new graph, and it automatically figures out from the CSV file the number of nodes and edges in the graph. So you can click OK, and so the network is loaded. So if you go to the data laboratory, the nodes and edges, or nodes, this is a nodes tab and this is the edges tab, so you can see the edges are displayed as source and target, and they're undirected, and some ID is given for the edges, and then each edge is having a weight of 1. Okay, so you can get those information. Now click on the overview tab on the top. Now that shows you the kind of network, and click on now the choose a layout pull down menu and select Fletcherman Green Gold. Okay, Fletcherman Green Gold, and click run. So it kind of tries to lay out the network in a more appropriate manner, and once you don't see any movement here, you can click stop. Okay, so you can get a preview or view of this network more visibly. Click preview and click refresh. So when you click refresh, whatever was there in the screen before disappears, and the network appears. Now you can make the edges to be dark. By default it is mixed, so you can click the color option under edges, and you can click custom, and you can color whatever the thing you want. I just leave it black and click OK, and every time you do a change, click this button, and the black color edges appear. You can make the increase the thickness of the edges, and click the button again to see the update thing, and also you can play with whatever you want, the different things, and then the width of the nodes you can make it also 2 to increase the dark color around the nodes. So this is kind of the initial loading up of your network. Now let's go and now calculate some statistics here. So we can calculate the average degree of the nodes, and this is a distribution of the degree. This is just a count, so which means how many nodes have degree 1, which is 1, how many nodes have degree 2, which is 11, how many nodes have degree 3, which is 6, how many nodes have degree 4, which is 6 again, and so on. Now we can also calculate the network diameter. When you click on that, it will ask you as undirected, directed. Don't choose the normalized centralities thing. You can do it, but it's better to just get the absolute values of the centrality, so we'll just choose leave it without being selected, and this will let us to calculate the betweenness centrality, closeness centrality, and the eccentricity. So it shows you the distributions of the centrality measures. Now click on modularity. You can select both randomize and use weights. So this will find the communities in the network, the optimal number of communities. It says it is 4, and the modularity score given here ranges from 0 to 1. So don't confuse this modularity score with the modularity score that we did in class. This is kind of another algorithm, not based on eigenvectors. This is based on another algorithm, this algorithm that is used to find the optimal modularity, and so the scores range from 0 to 1 in this case. Okay, so the closer it is to 1, the more modular is the network. In this case it is 0.411, so you can get a feeling of how modular is the network. Now clicking on connected components gives you the number of components in the network. So it says number of weakly connected components is 1. So this is an undirected graph, and if the number of components is 1, it means all nodes are in one single component, okay, reachable from each other. And click on average clustering coefficient. That's going to get you the clustering coefficient, the local clustering coefficient of all the nodes in the network. Then you can also find the eigenvector centrality of the nodes. Okay. Now you may be wondering, these values are not that visible, how do I collect these values? So now go, after you click on these things for statistics, the ones that you need for your project, go to the data laboratory section and click on nodes again. Now you see whatever you calculated there, the values are listed here. So these are the node IDs, okay, and these are the, of course you can sort it out in Excel in increasing order of the node IDs, so I'll show you that. So these are the different nodes and the different values for the metrics, the degree, eccentricity, everything that we calculated. Okay. So now two things. One thing is, can I export this information to Excel? Yes. So click on export table. So it will show you the list of metrics and the node ID that you want to export. Select whatever you want. So in my case, I just want the, let's say I want ID, degree, closeness, centrality, and betweenness, centrality. Okay. Or probably eigenvector centrality, and let's say clustering coefficient too. So let's see. Let me do it one more time, because I just want to say you can select the separator you want. So by default it is space, so you can select the separator to be comma, semicolon, or anything. Okay, so let's leave it as space. So after selecting the number of all the fields, so let's say I just save it as a CSV file, because that's the only option it provides you in Gephi. So it says table exported with success. So now try to open the data. The CSV file, so it opens like this. So now in Excel there's an option, so just select the first tab A and say click on data, say separate text to columns. So it's going to separate using delimiter. So here is where you can pick whatever delimiter you want. So I just, space is sufficient for us because that's what we used. Okay, so just click next and then finish. So it has separated things based on the space. So it's still a CSV file. So I suggest you to save it now as Excel file. So now you can save it as an Excel file. So I use Excel 2003. So whatever the name you want to give is fine. So I just say Kata network metrics. So this is Excel 2003. So you can do the same thing in your version of Excel. So just relabel this as metrics. So I think that if you save it as a .csv in the label here, it may create a problem. So that's why it's better to relabel whatever the .csv, everything, remove it and just say metrics here for the spreadsheet. So now it's up to us to play with this Excel spreadsheet. So we can sort the things based on the ID. So let's say select everything and click sort. And I want to have an increasing order of IDs. So everything now will be in increasing order of IDs, 1, 2, 3, up to the 34 nodes in the Karate network. Okay. So now we want to, let's say, get the degree distribution of this network. Okay. So in Gephi, we saw this version, isn't it? So if I click again, you can get the graph. So this is the distribution of the degrees of the nodes. We can get a similar thing in Excel. So for that, we have to just find out what are the different degree values of the nodes are. So the degree values of the nodes are, again, if you go to Gephi, you can find out the degree values are 1, 2, 3, 4, 5, 6. There's no 7, there's no 8, there's a 9, 10, there's no 11, 12, and then you have 16 and 17. So we can make it easy by, okay, so let me make a copy of this. So we can say move copy, then create a copy. So now I can sort this based on degree, so it becomes easy for us to count. So let me sort based on degree. So one node has degree 1. Now these are the nodes that have degree 2. So that is like what? From nodes from this 3 to 13. So that's going to be 11. Then degree 3 you have from 14 to 19. So 19 minus 14 plus 1 is 6. Of course you can count the number of 3's and number of 2's that are there. And this is 4. So 20 to 25 is 6 again. There are 3 nodes with degree 5. There are 2 nodes with degree 2, 9, degree 9. There's 1 node. Then 10, there is 1 node. 10, there is 1 node. 12, there is 1 node. 16, there is 1 node. 17, there is 1 node. So this is the degree distribution. Now we can first try with this, just the raw data, and we can get a plot of the degree distribution like this. Okay, so we can label the x-axis as degree, and then this is a count of the degree. But instead of getting the raw data, it's better to get the probability distribution. So which means, so this is the degree, this is the count of the number of nodes with the degree, and now the probability of the degree, or we can say probability of k, if I say degree is represented as k, is nothing but divide each of these by the number of nodes in the network, because this should sum to the number of nodes. So you can also cross check like that if you counted everything correctly. So sum of J2 to J12 should be 34, the total number of nodes in the Karate network. So I'm going to divide each entry, J2 divided by 34. That's this, is this. So this is getting me now the probability of finding a node with a certain degree. So now I can actually plot the degree and the probability. So let me copy it. So I can plot, right, when you copy in Excel the ones with the formula like J2 or 34 or something, when you copy and paste in another column, you have to copy and paste it as values. So click on this paste button, paste values, so it copies the same values. Otherwise it messes up your results. Okay, so now select the 2 things and then click on this bar icon, click on XY scatter, this, so it gets you the same figure, but now it's more like in a probability. Okay, so you can label this as your degree. I can remove this, and then this. So this is my degree, and probability of finding a node with a certain degree, so you can label it like this. Okay, so this is for the degree distribution. Okay, so now let's go back. Now regarding the layout, we can see here there is something called color. So you can color the nodes, and also you can resize the nodes, and we can do some labeling, which we don't do typically because the nodes, there are several nodes, so even if you label them, it's not that visible. So now that we have calculated several metrics, we can compare the trade-off or evaluate the trade-off, or not evaluate, kind of visualize a trade-off between the two metrics. So let's say we are comparing degree and between a centrality. So you decide which node you want, which metric you want to use for color, which metric you want to use for weight. So let's say I use betweenness centrality for color. So the values of the betweenness centrality in our graph ranges from, it shows the values 0 to 231.071. So of course you can click this button or this thing icon here, and it will show you the different coloring options. So you can color different things you want. I typically just use the black and white color, but if you want, you can choose any other color to make it more visually informative for you. Okay, you can even choose I think black and white is more easy because it shows the transformation from one range to the one end of the range to the other end. So if you click on apply, it's going to color them. Of course, we have not resized the nodes, right? So let's do that. Let's click on the size thing, and you can play with the minimum size you want for the nodes, and of course you have to select the metric. So make sure you go and select the different other metric you want, and so in this case you can have the range it's given for this network, the range of the degree is 1 to 17. So you can now play with the size you want. So you can even set 10 and 10, so everything will be the same size. You can set 10 and 1000, then the one with the smaller one will be 10, and the one with the 17 will be like of size corresponding to 1000. So you have to play with the minimum and maximum size. I'll show you that. So for this 10 and 100, let's click on apply. You see then this node has a larger degree, so that's why it is bulk. And if you put 1000 here, it's going to be really huge. Okay, so let's put it back. So every time you make a change, click on apply. So now go to the preview button. It's going to be the previous version of the network that we had seen. Now, since you made the change, you have to click the refresh button, and it is going to now show you the updated layout. So you see here, this node has the largest degree, the black. It's really black. This reason, as well as it has because the largest degree because of the shape, probably. This I think is even larger. Yes, so this is even larger than this one, but the color is used to distinguish between a centrality. This black color, since we use color for between a centrality, this is really dark compared to this. So this one has really a larger between a centrality, even larger than this one. Okay, and this one is even having a reasonably larger degree, but the between a centrality is not. So you just keep the current color scheme. So it's reasonably larger. Okay, but you see here this node has a degree of 4, but its between a centrality is almost kind of close to 0 because it's really white. Okay, so you can play with the color for one metric and the shape for the other metric. So if two metrics are really kind of positively correlated to each other, then it means what? The larger the degree, the larger should be the between a centrality, and so on. Okay. Okay, let's now go back to overview and let's compare some two other metrics. Let's say we use eigenvector centrality instead of degree for the size, and eigenvector centrality values range from 0.073 to 1. So let's click apply here. So now you see some changes. So go to preview. So if you just leave it as it is, it's not going to show you the updated graph. So again, click the refresh button. So now you see here, so now what did we use? The shape, right? So there are some reasonably big nodes having a high eigenvector centrality, but they have low between centrality, and this node still has a larger eigenvector centrality also, and a larger between centrality. Okay, this node has a little larger eigenvector centrality, but its between centrality is quite low. Okay, So if you want to take a screenshot, click on view and then click on full screen and again click this button, and you're going to get the you will be able to take a screenshot of it. So click print screen on your keyboard and go back, come back to the normal screen, and then you can click on paintbrush. So paste it and take a screenshot so you can take crop. Let me see, you can cut it more closely. So pull it down sufficiently so that the bottom part is covered, and so this is your network, so this is your layout, so you can even copy and paste this to your results Word document. Okay, so you can paste it in your Word document. Okay, and then you can adjust the size the way you want. Okay, so you can label it. This is to look at the trade-off between eigenvector centrality and betweener centrality. Okay, so now go back to overview. It can also give the path length. So the average path length is also, you can click on average path length or network diameter. That will find you the betweeners, closeness, and eccentricity. Okay, so it's just playing with these things. So now if you would just want one metric, just select the same metric for both the color as well as the size. Okay, so let's say I want just a degree, so I just make sure I select the degree, click apply, and go to the size thing. Degree is automatically selected because whatever you just selected previously it's shown for the next main icon too. So click apply. So now this layout graph is just showing you see now this node is darker as well as bigger because we are using the degree for both size as well as color. Okay, so the larger the degree, the darker the node as well as the larger the node to look at. Okay, so we'll stop here.